Hello, everyone. My name is Sirivarma Vegiraju. First of all, I would like to thank CSharpCorner for giving me this opportunity to present my talk on this topic, simplifying multi-cloud observability. In this session, we'll talk about multi-cloud observability, what are the complexities of observability in a multi-cloud architecture, and how to simplify it. Before we deep dive, a little bit about myself. I am Sirivarma Vegiraju, a software engineer at Microsoft, previously at Oracle. In my free time, I love to contribute to open source, and I'm an avid hiker. Currently, I live in Seattle, and Seattle summers are the best, and a hike on a weekend is what makes it more amazing. I also love to review books, and this is my LinkedIn, email, and Twitter. Please feel free to reach out to me if you have any feedback or if you want to talk anything about cloud, observability, software engineering, and distributed systems in general. I'm always open to talking to folks and learn from their experience. With that, let's get started with the talk. So looking at the agenda, first, we'll start with what is multi-cloud, why is it gaining a lot of popularity, and what are the motivations behind enterprises moving towards this architecture. Next, we'll look at observability. What is observability? How does observability help you track your service health? And what are the three main concepts in observability? Then we'll take a look at why the observability approach needs to change between a single and multi-cloud environment. What are the things that demand a change in approach when considering the multi-cloud architecture? Then we'll take a look at the complexities and how to simplify observability. And at the last, we'll conclude the talk. So what is multi-cloud and why is it gaining a lot of popularity? You see, when cloud was just a buzzword, people or companies hosted most of their services on-prem. When cloud adoption started, companies started hosting some of their workloads on cloud and on-prem. That is when they called it hybrid cloud. And then as the cloud adoption became stronger and as sophistications in how we build software grew, and building data centers is also not cheap. So companies started completely using cloud. And when I, as a company, use more than one cloud provider to serve my software, that is when I call it as a multi-cloud architecture. And a staggering 98%. This is part of a recent Oracle survey where what they have seen is 98% of enterprises, 98% of enterprise companies are either thinking about the multi-cloud strategy or are already on the multi-cloud strategy. And the key motivations for these companies to move towards this approach is first, data sovereignty. So consider I'm an enterprise company. I have my customers worldwide. I have them in different continents, geopolitical regions, and different countries. And each country has their own GDPR, has their own data privacy and protection laws. For example, United States has its own data privacy and data protection law. European Union has GDPR. Similarly, India, China, Japan, Australia, all these countries have their own laws. And if I, as an enterprise company, understand that my current cloud provider does not allow me to or uh, does not allow me to use some of these capabilities, that is when I would choose another cloud provider. Basically, where I get to is the cloud provider does not meet my needs. So I have to go looking out for another cloud provider. That is one reason. The second reason is vendor agnostic. If I, as a company, depend on a service that cloud provider offers, and if for some reason either the service is being deprecated or the cost is being increased by the provider or the features drastically change. I, as a company, want to be agnostic of this. I don't want my business deadlines to be affected because of these changes by the provider. And that is one more reason why I would be vendor agnostic, and that is when I would choose a multi-cloud architecture. Third, cost optimizations. If I think about it, every cloud provider has their own strong points. Some offer free egress and ingress, some offer cheap storage, and some offer free VMs or cheap VMs. Now, if I, as a company, am in a place to use these features, then I can significantly reduce the cost it takes to run my services on cloud. And we all know that running services in cloud is pretty expensive. So keeping a vendor agnostic architecture will help me leverage these features and scale better. To conclude, the three main motivations being data sovereignty, cloud vendor agnostic, and cost optimizations. Of course, there are other things as well, but these are the three main contributions. Next, we'll take a look at observability. So what is observability? Simply put, the ability to measure the current state of my system. Is my system healthy? Is my system, the request latency is low? Am I meeting my service level SLIs, SLOs, and SLAs? All these answers I can get from observability. The better the observability story for your company or for your product, the better you're able to serve your customers. And there are three main concepts in observability: metrics, logs, and traces. And let's look at each of them. So coming to metrics, metrics are the numerical representations of your system performance. For example, let's say I am serving a request and I emit a 1 for a success and 0 for a failure. Now I'm able to plot a mean of this graph, which gives me your 5 nines or 4 nines of availability. And if I, as a company, promise above 3 nines or 4 nines of availability, these metrics help me understand if I'm able to meet that. And if not, I monitor, I write alerts so that I understand the system degradation and can mitigate the problem as soon as possible. And coming to metrics, there are four main things. One is your request, the total number of requests it is taking, edits or your availability metrics, duration metrics, which are your request latency metrics, how much time it is taking to serve a request, and your saturation metrics, which are your CPU utilization, your memory utilization, and disk utilization metrics. Next, logs. With logs, there are mainly two types: audit logs and your debug logs. With audit logs, they are for your mostly control plane and data plane operations. For example, let's say somebody creates a VM, deletes a VM, or updates a VM. I, as a company, would want to know what is happening. For example, let's say there's a threat actor that has entered my system and is randomly creating resources, increasing my cloud cost. So I would want to definitely monitor these, and that is where audit logs do definitely help us. Then we have the debug logs. Debug logs are things like your stack traces. For example, a request failed. How do you handle that? What is the reason the request failed? This is where stack traces come into picture. And also you can add additional metadata that help you further debug a request. Traces, on the other hand, in a cloud distributed system world where there are a ton of microservices, you would want to understand the lifetime of your request. For example, let's say a customer tells you that, hey, your request duration is high. your request latency is high, and your request travels to 6 or 7 different microservices. If I want to debug where it is taking a lot of time, I would want to understand where all the requests travel to and what is the latency at each microservice. Traces help you with that. It helps you identify bottlenecks and dependencies so that you get a holistic view of the system. So metrics, logs, and traces as a whole give you the entire observability story for your service. Now that we have fundamentals in place, let's look at why the approach to observability needs to change in a multi-cloud environment. Before that, some stats. On an average, a company using cloud to offer the services uses at least 15 different services. What I mean by that, for example, let's say I am a provider that offers logging product to customers, right? Where customers can come and ingest logs and search to them. What are the services I'll be leveraging if I'm using cloud? I might use an API gateway to route my request to different services. Then I have my load balancer, which we use to distribute requests across VMs. You have the VMs itself. Then you might use an Azure storage queue where you store all the logs. And then you have additional NoSQL databases to store your data, then storage, network. So if we just think about this, we have just listed down at least 13 or 14 different services. Next, a company uses at least 9 different observability or monitoring tools to manage their application infrastructure and user experience. By looking at the stats itself, we can quickly understand how complex it becomes as the number of moving parts grow. So this is the example of a code snippet I have where I'm just using the single cloud. So I am using the Azure Monitor SDK to emit metrics to the Azure Cloud dashboard, right? So in this case, I'm using a metrics client emitting a data point, and I can see that on the cloud provider dashboard. In this case, I'm just using one cloud provider. Everything is pretty smooth. I can set up monitors using one of the Azure services, and my service is empty, right? Now let's take a look at how this changes in the multi-cloud world. So this is the code where I am using 4 different cloud providers, right? Of course, this might not be practical, but let's consider 2 of them, right? So let's say I'm using Azure Monitor and Google Cloud to emit my metrics and logs. So here in my code, I have 2 SDKs. And then on the right, what I see is 2 different dashboards to emit. 2 different dashboards I have to keep track of for emitting metrics and logs, right? From just the looks of it, we can quickly understand the complexities in cloud and operations. The complexities in cloud and operations the companies would have. So let's take a look at the complexities, right? First, because I'm having multiple SDKs, I have to maintain them. Either version updates or something regarding the SDK changes, have to maintain that. It is a continuous pain point. Second, I have to understand various cloud providers' implementations. Every cloud provider has their own schema, has their own way of representing dashboards, has their own SDKs, which makes it tricky when I'm on call. Imagine I being an on call and I have to go to 3 or 4 different runbooks to understand if each cloud provider's work. And then on parallelly, I'm getting paged for different services, for different problems, right? And then the schemas that each provider also offers is different. For example, let's say I have to search logs. And now what I end up is I have to go to each runbook, understand what the schema is in this cloud provider, and then search that. And when you're on call and when you are taking a lot of heat, this becomes added. This adds more trickiness to your day. So how do we solve this? How do we make operations, or how do we simplify operations? If I take a step back, what is the problem that I'm seeing here? Because my tools are tied to a specific vendor, I'm not able to offer a unified experience to my employees or to my devs, right? So if I was generic enough, and if I design my architecture in a way that I'm agnostic to a cloud vendor, I can make operations smooth, right? So this is where cloud native comes into picture. So with the adoption of cloud growing at a rapid pace, a lot of open source tool came into picture. For example, you have your Kubernetes infrastructure, which started 10 years ago, and now Kubernetes has become a de facto for running services. Similarly, there are a bunch of other open source tools as well. So today, what we will talk about is one such open source tool called OpenTelemetry, right? So what is OpenTelemetry? Simply put, it is an open source standard and specification to emit your metrics, logs, and traces, right? So and also the major cloud providers like AWS, Azure, GCP, and Oracle already support this project. This is a cloud native computing foundation project, and many of the cloud providers do already support this. And the best part, it is vendor agnostic. You are not tied up to any specific cloud vendor, which is very critical when you think about a cloud, when you think about a multi-cloud architecture. So let's get deep into the OpenTelemetry world. What does OpenTelemetry have? So first, it has a specification. Specification talks about what I need to do when I want to implement OpenTelemetry in a specific language. We as developers don't deal with this regularly. This comes into picture when you want to implement OpenTelemetry in a specific language, right? And by the way, OpenTelemetry already supports a bunch of different languages: Go, CSharp, Java, Ruby, all these languages. Next, semantics. You remember the problem we discussed about not having a common schema? With semantics, we can define common schemas that get propagated to different cloud providers, which will help you querying your metrics, logs, or traces easy. And then we have the SDK itself. This is what we will use to emit the metrics, logs, to emit your observability metrics and logs. Fine. And next, there is an exporter. This is a fundamental piece in this whole architecture. Once we emit metrics, logs, and traces using the SDK, each cloud provider has their own exporter. Azure Monitor has their own exporter, AWS, Google Cloud, Datadog, Zipkin, all these have own exporters. These exporters query the OpenTelemetry SDK and then export those things into their own backends. And that is where we talk about the final piece, where backend is every cloud provider's own implementation. For example, CloudWatch can be AWS backend, Azure Monitor can be Azure's backend, and Google Cloud has similarly its own backend. To summarize, there are 5 different components in the architecture here. One is your specification, mostly comes into picture when you implement a specific language. Semantics that help you define a common schema. The SDK itself, which you use to emit metrics, logs, and traces. Exporter, which the cloud providers already provide, and they are open sourced. You use these exporters to send the metrics, logs, and traces to the backends and the backends itself. Now, let's take a look at the architecture. We'll take a look at how in the world before OpenTelemetry, the architecture is, and currently with OpenTelemetry, how you can change this. So on the left, you see that you have a VM. The VM has your service, and the service is using the Azure Monitor SDK to emit metrics to Azure, right? Now, from whatever fundamentals and whatever discussion we had till now, what we understand is tying up the service to the SDK in a multi-cloud world causes a trickiness. Here, what we are doing is replacing the SDK with the OpenTelemetry SDK, right? The VM is same, the service is same, but the SDK itself changes. And then we have the cloud-specific exporter. To clarify, this is not any sidecar, or the exporter is not a sidecar. It is just another package in your C# or a Maven dependency in your ops, right? As part of your service, you emit metrics, you emit the observability pieces using the OpenTelemetry SDK, and the exporters extract those pieces, do any necessary processing they need on them, and then send it to the corresponding backends. In this case, Azure. Right. So this is the code snippet from when I'm using OpenTelemetry. So what I have here is a meter and a counter, right? These are the namespaces that belong to OpenTelemetry. And then I am adding exporters, something like this. So the exporter we discussed previously, we are adding it like this, like a Prometheus exporter and a console exporter. Similarly, I can add Azure exporter, Google Cloud exporter, right? And the amazing part is, if I see here, the way how I emit metrics does not change. So if I compare my slide to the previous one where we had 4 different SDKs, see the simplification that this infrastructure helps us. And tomorrow, if I want to extend it to a different cloud provider, I just need to add the exporter and an endpoint, right? That's it I have to do. I don't have to change any schema, any namespace, or anything of that sort. And this also helps you abstract these pieces out into a library so that you don't have to touch these pieces every time, improving your maintainability in the code. So this addresses our SDK concerns, right? Now, this is how the scenario would play out when you're using more than one cloud, right? In all the 3 cases here, what I have is the VM service and the SDK. None of these change. The only things that change is a package, which is your exporter, right? These are the only things that change. And then, of course, the backends, if wherever you want to export. Another thing that we discussed is not having a seamless experience for your dashboards, right? This is where Grafana comes into picture. What you can basically do is with Grafana, configure data sources that belong to each cloud. For example, AWS has its own data source, Azure has its own data source, GCP has its own data source. And what Grafana will do is it export all those things into its own dashboard and provide one seamless experience. So where did we start? We started with not having a unified experience, having multiple SDKs and multiple dashboards, right? To now where we are is one seamless experience, just different exporters, which are already provided to us by the cloud providers, and then one single dashboard. See how we have streamlined the pipeline to make the experience much better for our devs. Now they are very much happy, right? So this is how you can provide one seamless experience and decrease the pain that operations have to go through. Next, so this is a good to know. Not you don't have to. We as developers don't deal with this regularly. This is how cloud providers implement OpenTelemetry, right? So on the left, what you see is everything of this sort remains the same. But instead of talking to the Azure backend itself, the cloud provider talks to an agent, and the agent is the one that exports metric to the Azure backend, right? So this is normally what ends up happening is if I want to send any of the observability stats from my VM to a machine, agents are the one that used to do the job, right? Now I also want to provide backward supportability and also support the new ways of doing this things. So this is a good way to this is a good segue where I'm also supporting the current infrastructure and the OpenTelemetry infrastructure as a cloud provider. On the second architecture diagram, what you see is an collector, right? So collector is nothing but a combination of multiple processors and multiple exporters, right? What I can do is, so this, because this collector is an executable, it might end up taking a lot of space on your VM or a lot of memory on your VM. Let's say I want to limit that. That is when I can have a processor to limit the usage of memory for this collector. Similarly, let's say when I'm a cloud provider, with the telemetry the customers are providing me, I also want to add some additional metadata. I want to do some massaging on the data. That is when I would also add additional processors. So if I think about it like a big data pipeline, I have the source, I have multiple processors, and then I have multiple exporters. And each exporter can send data to one of the backends, right? So this is one more architecture. To conclude, what I would say is if companies want to adopt multi-cloud strategy and if they want to grow in that space, being vendor agnostic will help them definitely scale. If it is single cloud, then it does not matter much, but being vendor agnostic will help them scale and help them offer their customers better experience and ship features faster. Then you have your apart from these open source toolings, there are some other open source toolings as well. For example, with Prometheus, you can set up or emit metrics. Loki is also similar to Prometheus, but for logs. This is a plugin by Grafana. And then you have Zupkin, which is responsible for your traces. So all these have corresponding exporters, and you can just send the data to the backends, right? With that, I would like to conclude my talk. Thank you everyone for taking the time to listen to me. If you have any additional feedback, please feel free to reach out. Thank you.